In this video, we will show you how to install Quobyte on Google Kubernetes Engine in just a few minutes. You can find all the scripts and Helm charts on github.com/Quobyte. In this repo, you will find the steps to set up Quobyte to provide persistent storage to your applications running on Kubernetes. We will start with a Kubernetes cluster with 4 nodes. After reconnect to the cluster, we need to add the Quobyte repo. Next, we will deploy Quobyte using the single Helm chart. This starts the Quobyte services and containers in your Kubernetes clusters and runs the different services as stateful sets with the number of replicas that you specify. The Quobyte services need to store data persistently, and for that, we use persistent volume claims. In the values.yaml file, you can specify the provisioner of your cloud provider, in this case, Google Cloud, and the type and size of storage, and then the services automatically request persistent volume claims, which is where Quobyte stores raw data. Once the installation is complete, you can check the persistent volume claims for the Quobyte services. Next, let's get the IP address for the Quobyte web console using kubectl. Copy the external IP address, paste it into a new window, and add port 8080. This will load the Quobyte web console. Now you can set up an admin account. Please note that you will need to add these credentials base64 encoded in a YAML file for the next part of the demo. We can also configure which host IP addresses should be trusted to run Quobyte services. You can skip the license step, but if you are interested in a free license, make sure to visit quobyte.com. Once the account is ready, we can see that we have an empty Quobyte cluster. The next step to access Quobyte from Kubernetes is to deploy the Quobyte client and Quobyte CSI charts. The Quobyte client runs on all worker nodes on your Kubernetes cluster. It automatically mounts new volumes and makes them available to the host via a bidirectional volume mapping. On the other hand, the Quobyte CSI plugin is responsible to fulfill all the PVCs that have a storage class configured to use Quobyte. The Quobyte CSI plugin also creates a Quobyte volume quota for PVCs that have a size. Now we are ready to provision and mount persistent volumes backed by Quobyte. Next, we will go over an example where we will provision a persistent volume and mount it later onto a container deployed as a single pod. The example can be found in the Quobyte repo. Once we cd into the directory with the example, we need to apply the example declarations. These declarations will create a Quobyte namespace, the user and password that we mentioned earlier, the Quobyte default storage class, the test PVC, which requests a persistent volume from Quobyte, and a test pod, which will run an Nginx server. To check if the PVC was successfully created, we can retrieve it and describe it using kubectl. The information displayed confirms that our PVC was created, and we can see some details about it. Next, we can check if the persistent volume is mounted inside a container. Now, let's check if our Quobyte mount is readable and writable from within the container. Let's write hello world to an index.html file. And let's read it. This confirms that our Quobyte mount is writable and readable from within the container. As you can see, with a few simple steps, Quobyte allows you to provide persistent volumes for any application in your Kubernetes clusters.